Hello again, beautiful people. Who's excited to do some geometry today? Everyone's raising their hand? Good, because I'm excited also. Today, we're talking about area. Now, last class, we learned about circumference and arc length. Today, we're talking about area and sector area. So, before we get started, we need to, before we get started, you know what we have to do? Yes, that's right. We are going to yay math via the video. You ready? So you have to respond when I ask the question. Okay? Okay. You gonna do it? Okay, we'll see. Ready? Yay math? Yay math. Good job. I'm so proud of you. Okay. So now let's first talk about the area of a circle. Area is how much space something takes up. So in my example below here, it's going to be how much this entire space takes up inside of the circle. Okay? And so you may already know this formula if you've learned it previously. We're going to remind ourselves, though, it is pi r squared. Okay? That, my dear children, is a very important formula to know. Okay? Unlike circumference, okay, let me just remind ourselves. Recall circumference is 2 pi r. So just be clear about the difference so that you don't get them mixed up. Circumference is 2 pi r. Area is pi r squared. There's no such thing as 2 pi r squared. It's just FYI. Okay, so let's do an example. Shall we? We shall. This first one says find area. Okay, easy peasy. Leave the answer in terms of pi. So our formula is pi r squared. But, what is the radius here? If the diameter is 16, the radius is going to be, 16 divided by 2 is what I meant to write, which is 8. Very good. Okay, so then I just plug it in. Area is pi times 8 squared. And remember, when I say to leave your answer in terms of pi, means you're not going to type the pi in the calculator. All you're going to be typing in the calculator is the numbers, 8 squared, which you can hopefully do in your head. Right, children? 8 times 8 is 64 pi. One last thing before we finish this problem is the units of measurement. Don't forget. So we have inches, and when we talk about area, we always say the units are squared. So 64 pi inches squared. And that's my answer. Look at that. Easy peasy lemon squeezy. Think you can handle that? Plug and chug? You're literally just plugging it into a formula. So that's area of a circle in general, of a whole circle. Now, what if you only want to find the area of part of a circle? For example, you have this circular pizza, and you're like, I want to share this pizza with my friends because I'm a nice person like that. And you cut it up, but then you're looking over at your friend's slice of pizza, and looks like their piece is bigger than yours. Well, that's just not fair. We all need to have the same amount of pizza, right? So what should we do? Well, we can calculate the area of our slice of pizza and then calculate our friend's pizza and compare to make sure that they're the same, because that's a totally normal thing that someone would do. So that slice of pizza, guys, is called the sector of an area. The sector of a circle, also known as sector area. Okay, so let me show you what that would be in my example here. The sector area here is just this part. It is the region bounded by the arc. So the arc here is RT, and then the two radii, SR and ST. Okay, so that's my sector of a circle, like a little piece of pizza or a piece of pie. Okay, there is no symbol for a sector, so you just have to write out the word sector, and then you simply name it with the 3 points there, starting with your end point R, then going to the center S, and the other end point T. So this is called sector RST. Okay? Now, just like with arc length that we discussed last class, sector area also has a formula that you need to know. But it's not hard. All you got to do is go back and remind yourselves of the area of a circle, which is going to be pi r squared. And we're going to apply that to our sector. But what we need to know is the theta. What is theta again? Remember, it is the angle. It's a variable that represents the angle here. So if that's theta, this here is r for the radius. It happens to also be the same here. Okay. So my sector area, the formula is the area of a circle, which is pi r squared, multiplied by theta over 360. Does that look familiar? Well, it should look a lot like the arc length formula that we talked about last time. Okay. Just going to highlight all of this. Boop, boop. There you go. Look how beautiful I did that. That is a formula you need to know. So theta is your angle of the sector. R is obviously the radius. Okay. All right. Remember, you can pause if you need to get caught up on writing if I'm going too fast. Okay. All right. So let's practice that together. Find the sector area of sector MNO. Leave your answer in terms of pi. So I'm going to highlight for you what I'm actually looking for here. So I'm sorry. Go ahead and fix that. That's not right. That's not how we name the sector. The order matter. I would know what you meant. But go ahead and change it. Fix it to MON. Okay, so we always want to have that center of the circle here. In the middle, in the center. Makes sense. Okay, so the sector is MON. So I'm going to highlight it for you. Okay. And this is what we're trying to find. Okay. Okay, so my formula is pi r squared times theta over 360. That is sector area. Just as a reminder, you don't need to rewrite that. It's already written above, but I like to always write it every time just to practice memorizing it, because you know eventually you're going to have to memorize this for your test. All right, now we plug in the lovely things that we know. We know the radius here is 18 meters. Wait, I don't want to do that color. We got to do some different colors. I don't know. What about green? Green's nice. Calming. Green is the color of the baby's room. The nursery is partially green. I'm going to throw that as a little pop quiz question on your next test. Just kidding. I probably won't. I'll forget. Let's be honest. Okay. Moving on. We're going to plug in the R, which is 18 squared. Also, we want to plug in the theta here. Theta is the angle, so that's going to be 100 degrees out of 360. Don't forget your pi, okay? But since I want to leave my answer in terms of pi, I don't type the pi in the calculator, right guys? You're only going to type this 18 squared and then the 100 over 360. You can actually type that entirely as 1 into the calculator. Some people prefer to simplify the fraction here first, which would simplify to, let's see, 10 over 36, and then you cut each of those in half. So 5 over 13, 5 over 18, sorry. But just for the sake of time, it's probably easier for us to simply type this all in the calculator, okay? Oh, I probably need a calculator for that. Silly Miss Coffee. All right, let me whip out my handy dandy calculator. Always got with me. And 18 squared, that's going to be 324. Multiply that by 100 divided by 36. And you're going to get, or sorry, divided by 360, not 36. It looks like we're going to get 90 pi, right? 324 times that divided by that. Yes, okay. And remember, we're going to leave pi in our final answer. Oh, wait, let's go back to our units of measurement. That was meters squared. Cool. So that is the area of sector MON. Okay, not too bad, right? Quick question before we move on to radians. Okay, make sure your answer, if I say leave your answer in terms of pi, another way to phrase that on your homework is the exact answer. Okay, that means I want this here is an exact answer. More specifically, okay, it means no decimals. Now this one worked out really nicely. We got 90, which is an integer, but let's say you had gotten something like, 10.3 repeating. You want to always make sure you convert to a fraction. Okay? We'll do some other examples later. You guys are going to do your homework a little bit later too. Okay? All right. So that is part 1. Then we're going to do part 2, which is even easier. So hopefully you thought that this was easy. And now we're going to do something even easier. Okay, but this is going to represent part 2 of your homework. So remember how when we talked about trig, we talked about radians. Okay, don't worry. We're not going back to trigonometry right now. But we do have to define what radians are. So just like we have units of measurement for length, like feet, or inches, or meters, or centimeters, and so on, there are different units of measurement for angles. What? That's crazy. I know. But there are. Only we've ever learned about is degrees. So we're adding in a new one here, which is radians. So here are some conversions you need to know. We know all the way around a circle. So if I go start there and go all the way around a circle, that is 360 degrees, right? Well, in radians, that's the same thing as 2 pi. Wasn't that nice? They made it super convenient. 2 pi. Weird. Okay, so let's see how that would relate to other degree measures. Okay, again, if I'm going, let me break it up for you like a coordinate grid. If I'm starting at this point and I'm going all the way around here, and that represents 360 degrees. It also represents 2 pi. How many radians would I go if I just went 180 degrees from this starting point? Well, if I'm dividing 360 by 2, I'm going to divide the radians by 2. So it's just 1 pi, which I can write as pi radians. So for every 180 degrees, it's pi radians. That is our most common way to convert between radians and degrees. If you get stuck, that's usually what we fall back to. But I'm going to show you an even easier trick. Okay. Let's keep going. Let's keep dividing by 2. So I'm going to cut that in half. So starting here, if I go just 90 degrees, which is half of 180, that's going to be 1/2 pi, which I like to write as pi over 2 radians. Okay, by the way, there's no symbol for radians like there is for degrees. So instead, we just abbreviate it rad, because it's so rad and cool. All right, so you're getting the gist? Let's do it one more time. What if I divide 90 by 2? That's 45 degrees. Okay. So that's going to be going half of 90, which is like that. Okay. What's 1/2 divided by 2? Do you know in your head? Can you do it without a calculator? 1/2 divided by 2? It's 1/4, so you would put pi over 4 radians. Okay. Now, those are some simple conversions to know. What happens if we have a super gross degree measure like 37 degrees? So I'm going to show you a little trick that we use when we're converting from degrees to radians and vice versa. All right, what color should we do now? I'm like running out of colors. I don't want to go too bright. Can you see this? Is this too bright? But it's a pretty blue. We're going to do it anyway. Okay. Are you ready for this? How to convert to radians. So when I'm giving you degrees and you're going to convert to radians, you're going to follow this rule. Okay? You are going to divide. Look at that. Degree, divide by 180 degrees, and then multiply by pi. Okay, let's do a little tiny example before we do the next one. For example, if I am giving you degrees, like let's say 20 degrees, and I want to convert that to radians, you're going to follow your steps here. Divide by 180. So that's going to be 20 divided by 180, and then multiply by pi. However, do you think I want you to type pi in the calculator? No, I don't. Duh. Okay? Obviously. What I want to do is simplify this fraction, which you are more than welcome to do in your calculator, even though you should be able to do this in your head because the zeros drop and 2 goes into 18 9 times. But you know what? If you want to type it in your calculator, you go for it. And then make sure you do, though, math frac. All right? So that's going to be 1/9 pi. So that is our answer. But I like to write it like this. When there's I always like to put the pi up in the numerator. Okay? So I can just move this little guy up here. No, don't make them smaller. Ugh. Go back to this. Move him. There we go. Up there. Okay? But if it's a 1, it's understood to already be there, so you don't need to write it. So your answer is pi over 9 radians. Da, da, da. Okay? So all we did is divide by 180 and simplify. And you just have to stick the pi on next to it, basically. Okay. Now, what happens if I flip it around? Let's say I'm reversing that, just like kind of working backwards. That means you are going to do the opposite of this in the opposite order. So first, instead of multiplying by pi, guess what you're going to do? You're going to divide by pi. Okay, when you do that, by the way, you're essentially, i.e., meaning you're going to cancel out the pi when you divide by pi, because there's already going to be a pi in your question, like in the radians. So to divide by pi would be the same thing as canceling it out. And instead of dividing by 180, you're going to multiply by 180. Okay. All right. Let's see what that would look like. Let me move these down. Okay, you're in my way. Okay. So, let's say that I have 5 pi over 4 radians. We're going to convert that to degrees. So the first thing is to divide by pi. Well, that just means you're going to cancel out the pi's. Okay, so just drop the pi's. Just leave them. Okay, you don't need the pi. Okay, just kidding. We all need pi in our lives. But not here. And then we have 5/4. So then we're going to multiply by 180. So on your calculator, you can do the fraction 5 over 4 times 180. Okay? So you get out your handy dandy calculator. You can either simplify. Oh, that one's already simplified. All right, so yeah, we would just type in that times that, and you get 225 degrees. So for every 225 degrees, that's the same thing as 5 pi over 4 radians. Make sense? Okay, why don't you guys, try this out. Do it in your notebooks, okay? And I'll come around and see if you did it right. Or maybe, how about this? You should pause the video now. Pause it. Pause. Well, listen to what I'm saying first, and then pause it. You're going to pause the video in a second, and then I want you to practice it and see what you get. And then you can press play for the solution, okay? Because it's important for you to try it on your own instead of just watching Miss Coffee do it. Because when you take your quiz next time, Miss Coffee's not going to do it for you, okay? I'm sorry, I can't. You have to do it. So, are you ready to pause? And pause. Right now. Did you pause? Better pause. Okay. So now that you have solved it and tried it out your own, you can unpause and we'll do this together. Okay? So we are going from degrees to radians. So that's going to be dividing by 180 and multiplying by pi, right? So I'm going to take 30, divide by 180, and multiply by pi. But remember, don't type pi in your calculator. That's just silly. Okay? Type in 30 over 180, which is going to end up being 1 over 6 pi, which I like to put that pi in the numerator. Okay? Either one is correct, though, so I'm okay with whatever you write as long as it's very clear that pi is not in the denominator. It's either in the numerator or it's next to the fraction. Okay, did you get it right? I'm so proud of you if you did. Okay, the next one is radians to degrees. So that's going to be dividing by pi and multiplying by 180. So remember the divide by pi, that's just taking your pi and canceling it out. So the first thing you really need to do is drop the pi. Oops. And we're going to get 3/4. Then the next step was multiply by 180, right? So times 180. Okay. And type in your calculator. Oh, you're genius. Beep, boop, beep, boop. 3 times 180 divided by 4. And you get, dun, 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 135 degrees. Did you get that one right? I'm so proud of you if you did. If you didn't, I'm proud of you for trying. And if you didn't try at all, I'm not proud of you and I'm extremely disappointed. Anyway, so now you're going to work on your homework, okay? Thanks for listening. Thanks for tuning in to Ms. Coffee and Geometry. And I don't have a good slogan yet for my YouTube channel that I'm going to be famous in, but I'll work on it, okay? Okay. Well, have fun and yay math.